Hello, this is your Dr. Bitlavenu. In this session, we will see the examples for the isometric views. In our last session, we have seen that introduction part to the isometric views. Then we have also seen that the isometric views for the planar surfaces like the cylindrical surface, hexagonal surface, pentagonal surface, rectangular surface. We have seen the front view and top view for the planar surfaces. Along with that, we have also seen some isometric views for the three-dimensional components also. But in this session, we will see some more examples for isometric views, which includes the cylindrical surfaces, spherical surfaces, such as the pyramids, cones, we will see in this session. Now let me move further to take one example. Then here we have one problem, that is projections of frustum of pentagonal pyramid are given. That means the orthographic projections are given in this problem. That is the pentagonal pyramid. Draw its isometric view. The dimensions are given in the problem. As you can see here, then let me take the pointer. Then in this case, as you can see, it is a pentagonal pyramid. The base of this pentagonal pyramid is lying on the horizontal plane, as you can see in this figure. It is the frustum of the pentagonal pyramid, as we are discussed in our last sessions. Frustum means the sectioned plane is parallel to the base. That means we are going to section the solid such that the surface of the sectioned surface or the sectioned surface is parallel to the base, or the sectioned plane is parallel to the base, as you can see here. So after doing section, the sectioned surface is parallel to the base like this. So the sectioned surface is at a height of 60 millimeters from the base that you can see here, and at a height of 60 millimeters, as you can see here, the base side of the pentagonal pyramid is 40 millimeters, and on the top, after doing the section, we will also get one more pentagon that is of side 20 millimeters. So with these dimensions, we need to draw the isometric view of the pentagonal pyramid, that is the frustum of pentagonal pyramid with the given dimensions. To draw these projections of the pentagonal pyramid, then uh, draw a rhombus with the dimensions of the pentagon. As you can see here, everything is given here, and the naming conventions are also given here, 1 2 3 4. And with those dimensions, draw the top view to inscribe the pentagon in this rhombus with a side of 40 millimeters like this. Draw an inclined line at an angle of 30 degrees and one more line from this point at an angle of 30 degrees. Then indicate a side, and this side length is given, that is 40 millimeters. Draw an inclined line at an angle of 108 degrees from this line, and from here also draw an inclined line at an angle of 108 degrees from this line. Then take the compass and with this point as center, otherwise you can take the midpoint and join this point and this point. We will get the top view for the pentagonal surface. Then the height of the pentagon is also given to us. So then indicate the midpoint to this pentagon and draw a perpendicular to this side, and similarly, and draw one more perpendicular to one more side, and both will intersect at this location. And from this will become the midpoint of the pentagon. And from this point, locate the height of the frustum of pentagonal pyramid. That height is 60 millimeters like this. Then project all the points of this pentagon like this with the same height, that is 60 mm, from all the points of the pentagon like this. Then join all those points like this. Then after joining all the points at a height of 60 millimeters, now we need to construct the sectioned surface of the pentagonal pyramid at a height of 60 millimeters. Now we are already drawn a pentagon similar to that of the bottom surface. Now the bottom surface is not, we are not going to get. Now at the top we will get the pentagon of side 20 millimeters that you can see in the top view of the projections. Then locate the midpoint on the top of the prism. Now it looks like a prism, but now originally it is not prism, it is the pyramid. Now after locating the center point at the top, then take 20 mm distance in the compass and locate the distance. To take any line and to this line and locate 10 mm, 20 mm. This will be the one, the side will be the 20 mm. Draw a line parallel to this, draw a line parallel to this line for a length of 20 millimeters, and here also draw a line parallel to this line for a length of 20 millimeters. Then take the compass, then get the distance here and get point here, then join all those points to get the top surface of the frustum of pentagonal pyramid. Then join all the points of the edges on top and bottom surfaces like this. This will become the frustum of pentagonal pyramid. Now I take one more problem. Now you can see, draw the isometric view of frustum of cone standing on HP on its larger base. So we have frustum of cone. This is standing on horizontal plane on the such that the larger base is on horizontal plane like this. Then this is also similar to the same problem, but here it is a pentagonal pyramid and it is also frustum of pentagonal pyramid. It is also lying on the horizontal plane. Of course, it is not mentioned, but here it is mentioned that the larger side of the cone is standing on HP. Similarly, this will be the front view and this will be the top view of the frustum of the cone. The height of the cone is 60 millimeters. Then the base diameter is 40 and the section surface is 20. Then draw a horizontal line. Then construct a rhombus or a box with the diameter. The base diameter is 40, that is already mentioned. With the base diameter, construct a rhombus like this. Then project all the points of the rhombus or the corners of the rhombus, 4 corners of the rhombus like this with a height 60 millimeters. Then join all the projectors to get one more rhombus on the top. Then divide this rhombus like this Then locate the center point. To the center point, locate the four points on these two perpendiculars. The distance between the points should be 20 millimeters, such that locate 4 points. Then otherwise draw a rhombus for a length of 20 millimeters like this. Then join the corners of the top rhombus to the bottom rhombus like this. Now draw the ellipse on the top view for the rhombus of length 20 mm side, and for the rhombus of side length 40 mm in top and as well as bottom, draw the ellipse like this. Drawing an ellipse with a given diameter, as we have seen in our last session, using that procedure, construct the ellipse on the top and as well as the bottom. On the top and as well as the bottom, with a given diameter, construct the ellipse, and this will become the top surface and this will become the bottom surface of the frustum of the cone standing on HP. Now join the left and right ellipses like this, and also we need to indicate this as a dotted line because this edge we cannot see, so that we have to indicate this line as a dotted line. Of course that is shown as a thick line here, but this line supposed to be shown as dotted line. Now after drawing the ellipse, draw the tangents for the top ellipse and bottom ellipse to complete or to get the isometric view of the frustum of the cone standing on horizontal plane, such that on its larger base is on HP. Now let me take one more problem. A square pyramid of 30 mm base side and 50 mm long axis is centrally placed on the top of the cube of 50 mm long edges. Draw the isometric view of the pair. In this case, we have two blocks. One is this cube of side 50 mm and a square pyramid of 30 mm base side and 50 mm long axis is placed on the cube. The cube is placed on the horizontal plane on which a square pyramid of side 30 mm is placed centrally. The height of the square pyramid is 50 mm. We have to draw the projections of this pair. One is cube and other one is square pyramid of side 30 mm and 50 mm long axis. Now first construct the cube like this with a given side, that is 50 mm. Construct the cube. Then after constructing the cube, then construct the square pyramid of side 30 mm and base 30 mm base and base sides, and its axis is 50 mm. Then locate the center point on the top of the cube like this. Then from the midpoint of the cube and locate a point Otherwise, construct the base of the square pyramid of side 30 mm like this on the surface of the cube like this. After constructing the rhombus or the bottom surface of the square pyramid, then locate the height. That height is 50 mm from the midpoint. Then this height is 50 mm as I said with you. Then join the apex point. So the height of the topmost point of this line will become the apex of the square pyramid. Join the top point of this line with the four corners of the rhombus, which gives us the pyramid, square pyramid lies on the cube of side 50 mm that you can see here. So the side of the cube is 50 and height is 50 mm, and the side of the pyramid, base side of the pyramid is 30 mm. This side is 30 mm. So this will be the isometric view of the cube and the pyramid, which is located, square pyramid located centrally on the cube. The side of the pyramid is 30 mm and height is 50 mm that you can see here. Now let me move further to see one more problem. A triangular pyramid of 30 mm base sides and 50 mm long axis is centrally placed on the top of the cube of side 50 mm long edges. Draw the isometric view of the pair. Now a triangular pyramid of 30 mm base, but in the previous case we have seen that the square pyramid is located centrally on the cube, on the top of the cube of side 50 mm, but whereas in this case the triangular pyramid of base side 30 mm is placed centrally on the cube of side 50 mm. In this case, we have to draw the isometric view of the pair. Now, similarly, like the previous case, construct a cube in isometric view like this of side 50 mm. Then after constructing the cube with the side of 50 mm, locate the center point on the top of the cube. Before that, it is a triangular pyramid of side 30 mm. Then draw the triangle of side 30 mm. Then locate O point, okay, like this, and this will be the center point. Then locate AB, but for the pyramid, as its base is an equilateral triangle. So before to draw this triangle, we need to assume something. But for pyramid, as it is a base, is an equilateral triangle, it cannot be drawn directly. Because of that, we have to construct the equilateral triangle first. So that's what we are constructing, the equilateral triangle like this. Then, so draw the triangle as top view separately and name various points as shown. After this, place this on the top of the cube as shown like this. Now locate the O point by drawing all the perpendicular lines AC, AB and BC. We will get O point. So after locating the O point, that will come by drawing the perpendicular lines to the sides of this equilateral triangle AC, AB and BC. We will get O point. After locating O point, then locate AB point from or at a distance of point O. Locate AB, which is perpendicular to this line. Then get the compass and locate C point. Locate C point by using the compass. Then join this point and A, and or name that point as C. Join AC and CB like this. After constructing the base of the triangular pyramid, now we need to locate the height of the triangular pyramid. From the point O, locate the height of the triangular pyramid. The height of the triangular pyramid is 50 mm. From point O, draw a vertical line for a length of 50 mm, and the top point or the end point of this line will become the apex of the triangular pyramid. Then join this point or end point or the top point of this line A, B and C respectively to complete the isometric view of the triangular pyramid placed centrally on the cube of side 50 mm. This is what the procedure we have to follow to place the triangular pyramid centrally on the cube, on the top surface of the cube like this. Now let me move further to see one more problem. A square plate is pierced through centrally by a cylinder. A square plate is centrally pierced through centrally by a cylinder which comes out equally from both the faces. As you can see here, a cylinder is piercing the square plate of 30 mm on the top of the plate, and as well as the bottom is also 30 mm. The height of the square plate is 10 millimeters. The other dimensions are also given. The diameter of the cylinder is 30 mm. Then the square plate side is 50 mm. So with these dimensions, we need to draw the isometric view of this figure. To draw that, initially draw the square or the rhombus here like this, or draw the plate for the lengths given, that is 50 and 50. This length will become 50 and this length will become 50, and this height will become 10 millimeters, which is given in the problem. So by drawing the projection isometric view of the plate of side 50 mm and height 10 millimeters, now we need to locate, or we need to draw the cylinder of diameter 30 mm, 30 mm above the plate and 30 mm below the plate, as you can see in the front view of the figure. So to that, first locate the center point. After locating this center point, okay, so this will be our center point. Then construct an ellipse with a given diameter. The given diameter here is 30. So with a given 30 mm diameter, draw the top view of the circular plane, so which looks like this, and we will get the center point, and from the center point draw a vertical line for a height of 30 mm. So before drawing these tangents, we have to draw the vertical line for a length of 30 mm. Then on the top of, or at the end of the top end of this line, construct one more rhombus, and in that rhombus draw one more ellipse. That means it is the top view for the circular plane at the bottom and as well as the top, we need to draw the top view of the planar surface. In both the cases, the distance between these two circular planar surface is 30 mm from this point, and from this point is 30 mm. And we are constructed the upper part of the cylinder. Now we have to construct the bottom part also. So when you see from this block in this view, we will not get this line because this is not visible. This will come backside, hence we are not showing that line. Then we need to locate the bottom portion also similar to this top portion. Then project the surfaces like this. Then construct the top view for the planar surface like this. And this planar surface is at a height of 40, as you can see here. Okay, so this completes the figure of the isometric view. That is, a square plate is pierced centrally by a cylinder which comes out equally from both the faces of the plate. Its top view and front views are shown here. Now let us see one more problem. A circular plate is pierced through centrally by a square pyramid. As you can see here, a circular plate we have is pierced through centrally by a square pyramid which comes out equally from both the faces, as you can see here. On the top face of the circular plate and bottom face of the circular plate, the square pyramid is piercing equally. On the top, its length is 30, and on the bottom, the length is also 30, that you can see here. The diameter of the circular plate is 60 millimeters. The base side of the square pyramid is 40, and the top face of the square pyramid is 20 millimeters. That is not shown in this, but you assume this length as 20. Now draw the rhombus first for the 60 mm length and 60 mm length for a height of 10 mm, in which we have to draw this circular plate. That means on the top we will get one ellipse, and on the bottom face also we will get one ellipse, and on the bottom face also draw an ellipse and draw the tangents like this, which gives us the circular plate, isometric view of the circular plate. Now on the top, locate the center point. At the center, draw a rhombus for a side of 20 millimeters, and from the corners from this rhombus, then otherwise from the midpoint, draw a perpendicular to this plane for a height of 30 millimeters. That will become apex. Then join the end point of that line with these four corners of the rhombus to get the pyramid surface on the top of the circular plate. Now we are completed the upper portion of the pyramid. Next step is to complete the bottom portion of the pyramid, which is below the circular plate. To that, next draw a line from this point for a length of 30 millimeters, and from the bottom, exactly from the bottom surface, from this bottom rhombus, and come down for a length of 30 millimeters, then construct one more rhombus at that location, then draw a line which is coinciding with this inclined line, which gives us the slant edge of the square pyramid. And similarly, also draw the line which is going to coincide with the edge, slant edge of the top pyramid. This is how we need to draw the isometric view of the square pyramid, which is pierced from the circular plate. Now let me take one more problem. Here we have a figure, we have the frustum of the cone, then we have a cylindrical portion on the top. On the top we have a slot. This is exactly the figure for which we need to draw the isometric view. Now construct the cube of side 40 mm. As you can see here, this is 40 mm and this is 50 mm. Initially construct a cube of side 50 mm in isometric view like this. Then locate the midpoint on the top of this cube. Then construct one more rhombus on the top of this cube for a side 30 mm like this. After constructing the rhombus, join the edges of the rhombus, 30 mm side rhombus and as well as the 50 mm side rhombus like this. After that, then draw an ellipse at the bottom and as well as the top surfaces like this. After drawing the ellipse on the top and as well as the bottom, draw the tangents for these two ellipses, which gives us the frustum of the cone. Then on the top, from the midpoint, draw a vertical line for a length of 40 mm first and construct on the top of this. The diameter is 30. For the 30 mm side, construct one more rhombus there. In that rhombus, construct one more ellipse, which gives the top surface of the compound figure, which is cylindrical in its shape. On the bottom, we have the frustum of the cone, on which we have the cylindrical surface. On the top of this cylindrical surface also, we have one slot that we need to locate. Then get the distances. Exactly take the midpoint and from the mid 5 mm and 5 mm and come down for a length of 20 mm. Then draw an arc here, which gives the complete figure of the isometric view for the given compound figure. Now let me take one more figure. We have a sphere here, as you can see. This is the diameter and radius is given to us, right? Then the C will be the center of the sphere. Then P will be the point of contact, as you can see here. Then R will be the true radius of the sphere that you can see here, true radius of the sphere. Then small r will be the isometric radius. This is the isometric radius and this will be the true radius of the sphere that is given to us. Then the problem is the isometric projections of the sphere and hemisphere we will see in this. Now to draw that, first Draw the isometric view of the square plate first, like this. Then locate the center and name that point as P, like this. From the P point, draw a vertical line. Draw a vertical line for the isometric, for a length of isometric radius, which will give us, otherwise join this point and this point, we will get the isometric radius like this. We just locate the point and name that point as C. Then with the radius, with C point as radius, with capital R as radius, draw a circle. Then this will be the same figure, but now let us see the procedure. Then construct the same. Now we are going to draw the hemisphere. This is exactly the sphere. Now this will be the hemisphere. As you can see here, up to here the procedure is same. Up to here the procedure is same. Draw the isometric view of the plate of height, so and so height, on which locate the point C, center point of the sphere. Then locate the true radius. With the true radius, construct a rhombus. With the true radius, construct the rhombus. In that rhombus, construct an ellipse. Then erase this line, which gives us a hemisphere is placed centrally on the square plate of so and so height. This is what the sphere and hemisphere isometric views. Now let me take one more figure. A hemisphere is centrally placed on the top of a frustum of the cone. Draw isometric projections of the assembly like this. Then first draw the cube of side 50 mm like this. Then with 30 mm side, construct one more rhombus. Construct one more rhombus like this. Then join the bottom rhombus and bottom rhombus corners, top and bottom rhombus corners like this. Construct the rhombus on the top and as well as bottom like this. Then join draw the tangents for these two ellipses, which gives us the bottom portion of the given solid, the isometric view of the bottom portion of the given figure. And this will become our center point. Then move up for a length of 25 mm. The diameter is 50, so that we need to move up 25 mm. Then this will become capital R and this will become small r. Then with a radius, draw the circle. Then with the true radius, construct one more rhombus at that height, in which you construct an ellipse. Then erase this line, which gives us the hemisphere placed centrally on the frustum of the cone. Now let me take one more problem. A square pyramid of 40 mm base, sides and 60 mm axis is cut by an inclined section plane to the midpoint of axis as shown. Draw isometric view of section of pyramid. This is what the problem. A square pyramid of 40 mm base, side and 60 mm axis is cut by an inclined section plane to the midpoint. Exactly at the midpoint, this square pyramid is sectioned with a section plane like this. Then locate the points 1, 1 dash, 1 dash 2 dash and 3 dash 4 dash, and project all those points on the top view. Then the edges are named as A, B, C, D. Then locate the points and project the points on the top view also, 1, 2, then this will become 3 and this will become 4. First draw the top view of the square pyramid, then draw the front view, then section the front view like this and name the points as 1 dash 2 dash 3 dash 4 dash and 1 2 3 4 like this. The bottom of the square pyramid as ABCD. So this is the given condition, and for this we need to draw the isometric view. To draw the isometric view with a given height, at the bottom construct one rhombus with a side 40 mm like this. Then locate all these points. Locate all these points on the bottom. Then name those points. And from this will become a 1, 2, 3, 4. And from the 1, 2, 3, 4 points. From the 1, 2, 3, 4 points. So then take the distance and take the compass from 1 and 2 points. Get the points 1 and 2. And similarly, get the points 3 and 4. From the points 3 and 4, locate the heights. So 1 dash 2 dash is at a certain height and 3 dash 4 dash is at a certain height. So take the compass and get the distance and draw the vertical lines from these 2 points and as well as these 2 points. Then join 1, 2, 3, 4 like this. Then join 3 and this corner, 4 and that bottom corner, 1 and this corner, and 2 and this corner. Gives us the isometric view of the square pyramid, which is sectioned at the midpoint of the axis as shown in this figure. And this will become the isometric view in this case. We are doing the section of this square pyramid exactly at the mid, and this will be the isometric view. So thank you for this session, and in the next session we will see the few more examples. Now, as of now, we have seen that the isometric view of the square pyramid sectioned exactly at the mid. Then we have seen that a hemisphere is placed on the frustum of the cone centrally. For this also, we have drawn the isometric view. Then we have also drawn the isometric projections of the sphere and hemisphere like this. Then we have also seen the composite figure, which includes the frustum of the cone and as well as the cylinder with slot. Then let us see that a circular plate is pierced centrally by a square pyramid which comes out equally from the both sides or the both faces of the plate like this. Then a square plate is pierced centrally by a cylinder equally from both the faces. For that also we have seen the isometric view. Then a triangular pyramid of base side is placed centrally on the cube of 50 mm side edge. That also we have seen in this session. Then a square pyramid of base 30 mm side and 50 mm long axis is centrally placed on the top of the cube of side 50 mm. That we have seen. Then we have also drawn the isometric views of the frustum of the cone Then we have seen the isometric views of the frustum of the pentagonal pyramid. This is what we are discussed in this session. Thank you. Thank you, one and all.